Today we're going to be talking about solving literal equations. A literal equation is an equation involving two or more variables. So everything we've seen so far has just been solving with one variable, trying to get x by itself, or m by itself, y by itself, w by itself, whatever variable it was. But we're going to be having two or more variables in these equations, and we're going to have to solve for one of them. And they're going to tell us which one to solve for. Now, to transform a literal equation, you get the variable you're solving for alone on one side of the equation. Doesn't matter if it's the left or the right. Our job is to get whatever variable they're telling us to get by itself on one side of the equal sign. Okay? So the first one we're going to do is we're going to solve 5x plus 4y equals 4 for y. They've told us that we need to get y by itself. So our job is to do everything we can to get this term by itself first, and then we're going to get rid of that 4 out front and get y by itself. In order to do this, let's look back and compare this to an equation we've seen in the past that only has one variable. So if we have 5 plus 4y equals 4, this only has one variable here, what would we do to get rid of this 5? That's on the same side as this y. We want to get rid of it first. So since this is a positive 5, we would have subtracted 5 on both sides. Now, that would give us 4y equals 4 minus 5 is a negative 1. Those two things are like terms to combine. Let's take a look and compare that same step over here. We're trying to get this 5x to the other side, so we're going to subtract 5x because that's the opposite or inverse operation. Those go away. We're left with 4y equals. Are 4 and negative 5x like terms, though? No, they're not. So you can either write 4 minus 5x or negative 5x plus 4. Doesn't matter at all. I'll just go ahead and write it as 4 minus 5x. Okay, y is still our job to get that by itself. We don't have it by itself yet. Okay, let's compare over here. We have 4 times y equals negative 1. To get y by itself, we would divide by 4 on both sides of the equation. And that would tell us y equals negative 1/4. Same steps are going to happen over here. It's just going to look a little different. 4 times y, to get rid of that, we're going to divide by 4. We're going to divide this entire right-hand side by 4. So 4, 4, those go away. Y equals 4 minus 5x over 4. Now you really can't simplify that much. You can't just cancel out these 4s and make that be a 1. You would have to simplify with this as well. So we're going to leave our answer like this. Your answers are definitely going to look way more complicated than they did in the past, but we got y by itself. That was the variable they told us to get by itself, so our answer is just this. Next one, we're going to solve f equals m times g all divided by d for m. Okay, so they've told us that we need to get m by itself. So we're going to compare this to a different equation that we could have here. Actually, let's do the first step first, and then we'll kind of compare. So we've got this all is being divided by d. We've got to get this m by itself, which means we've got to get mg by itself first. So this is all being divided by d. The way to get rid of division, the inverse operation of that, is to multiply by d. So we're going to multiply by d on both sides. Now, d times f. Do we know what those those variables are in order to multiply them? No. So we're just going to say df. On the right-hand side, we still have our m and our g, and the d's go away because d divided by d is 1. Anything divided by itself is 1. So we're still trying to get m by itself. All right, so let's compare this to a different equation. If we have 7 times 3 equals 4m, okay? Well, here we would multiply those together to get 21. Well, we don't know what d times f is, so we can't actually do that step. But our next thing is to get m by itself. So 4 times m, the inverse operation is to divide by 4. It's going to get m by itself on the right. Again, I told you it doesn't matter if you're getting it by itself on the left or right. We're here. And then 21 divided by 4 We can just leave it as that fraction. You could also get a decimal if you want. That's fine. So over here, we're trying to get m by itself. M times g. We would divide by g on both sides. D times f divided by g. Do we know what any of those variables stand for? We have no idea how to simplify any of that. So this right here is our answer. Our job was to get m by itself, and we did just that. All right, next one here. We have p equals 2a plus akr, and we're going to solve this for k. We're going to solve this for k. Now there is a lot going on in this question, or it appears, but we don't have to be scared by that. We're just going to take our time. In this, we are going to have to get k by itself, which means we need to get this term by itself first. That means this 2a. We're going to take that 2a, since it's positive. How do we move it to the other side? We're going to subtract it. P minus 2a. Do we have any idea what that is? No. So we're just going to copy that down. On the right-hand side, we have our a, k, r still left, and we're still trying to get k by itself. What's happening between a, k, and r? Well, all three of those are being multiplied by each other. A times k times r. The way to get rid of multiplying is to divide, and we can do this all in one step. But when we divide on the left-hand side, we're going to divide that entire piece of p minus 2a by ar. So p minus 2a over ar is going to equal k. Your answers for these literal equations are going to look very complicated. But as long as you're doing your inverse operations like we've been doing with solving equations, you're going to do just fine. All right, let's just keep trying different questions here. So now we're going to solve ax plus b equals c, and we're going to solve it for a. When they tell you for that variable, that's the one you're trying to isolate and get by itself. Ax plus b equals c. That means that we want to get the ax by itself, so we're going to subtract b on both sides. That means that we would have ax equals c minus b. We have no idea what c minus b actually is. We're still trying to get a by itself. A is being multiplied by x. That means we're going to, divide by x, because we're trying to get a by itself. We're going to divide that entire piece by x on the right-hand side. And a would equal c minus b all over x. We have no idea what any of those variables stand for, so we can't simplify them at all along the way. All right, here's this one. We have k equals m times the quantity p plus q, all divided by 2. And we're going to solve for p, this variable right here. Okay, since we're trying to get p by itself, that means that we need to get this numerator piece by itself first. Okay, that numerator piece by itself first. So how are we going to get rid of dividing by 2? We're going to multiply both sides of this equation by 2. 2 times k is just 2k. And on the right-hand side, those 2 divided by 2 becomes 1. So it's just going to go away. And we're left with, on the right-hand side, m times the quantity p plus q. Now there are multiple steps that you can do from here. Okay, different steps that you can take, different paths you can go. I'm going to, instead of distributing the m in, which is something that you can do, I'm going to not do that and know that since we're trying to get this p by itself, I'm going to get rid of that m. Well, this m is being multiplied, so we're going to divide it on both sides. 2k divided by m. No idea what that is. We're going to leave it alone. And that's going to equal p plus q. Again, we're still trying to get p by itself. Okay? To get p by itself, we need to get rid of this plus q, which means we're going to subtract q on both sides. 2k over m minus q. Do we have any idea what that is? No. We're literally going to write it exactly the same way we just said it. This q cannot go in the numerator with this, with the 2k, and it can't go in the denominator with the m. It's got to be just off to the side. It does not have a common denominator with this m in order to combine. There we go. We've got p by itself. That's the variable that they told us to get by itself. So we are good to go. All of these are going to do very similar things, but just be different variables, different examples, things like that. So we're going to do a couple more here, and then we'll stop. So we're going to solve 3c plus z equals 1 over w, or 1 divided by w, and we're going to solve that for z. So I went ahead and put a box around z. If we have to get z by itself, that means we got to move this 3c. We've got to get that. Well, how do we work on getting that to the other side? If it's positive, we're going to subtract 3c from both sides. Is this 3c, this minus 3c, like terms, and can we combine it with the 1 divided by w? No, it does not have a common denominator with it at all. So z is going to equal 1 divided by w minus 3c. And that's our answer. Again, your answers are going to look complicated, but you're still able to do the work. Okay? Just follow those inverse operations just like we did with solving equations. Here's our last one. We're going to solve g equals r squared h divided by 3 for r. Okay, we've got to solve it for r, which ultimately means we got to get r squared by itself. But before we can do that, we've got to get r squared h by itself. Since this is divided by 3, to get rid of that, we are going to multiply by 3 on both sides. So we have 3g equals r squared h. And again, we need to get r by itself. In order to do that, we got to get r squared by itself. R squared is being multiplied by h. So we're going to divide both sides by h. Do we know what 3g divided by h is? No idea. So 3g divided by h is going to equal r squared. Again, we're still trying to get r by itself. R squared. What's the inverse operation of squaring something? So that's going to be taking the square root. So we have the square root of 3g over h equals r. And we have no idea what the square root of 3g over h is. So we're going to leave it alone. And there's our answer. So the big thing to remember with these questions is not to get overwhelmed, and whatever variable they are telling you to solve for, you're using inverse operations in order to get that variable by itself.